Hello students, welcome to my session. Myself is Vanaja, lecturer in physics from Government Polytechnic Nirmal. Today we are going to learn about the velocity, acceleration, the frequency, time period of the particle executing SHM. It's the simple harmonic motion. The last session we discussed about the displacement of the particle in simple harmonic motion, that is y is equal to a sine omega t plus phi, where y is the displacement from the mean position of the particle and a is the amplitude, omega is the angular velocity, t is time and phi is the phase, indicates the initial position of the particle. Now in this session I will explain the velocity of the particle in executing SHM. So first of all, the particle, to explain this velocity in SHM, the particle is moving in the circular path, that is in x dash y dash path, as the center as O and the radius of the reference circle is A. The radius of the circular path is small a and O as center. The particle is moving in the circular path. And here after t time the particle is at P point, where the linear velocity of the particle always tangential to the circular path. So in the figure, v is the velocity, the linear velocity of the particle at P. So you can see the velocity, direction of the linear velocity at point P. So that is tangential at that point. So the velocity in SHM is the rate of change of displacement, is the velocity of the vibrating particle, as we know that. And by differentiating the equation 1, that is y is equal to a sine omega t with respect to time, we get the velocity in SHM. So the rate of change of displacement is the velocity. So as we know that displacement is y is equal to a sine omega t, just I am differentiating the displacement of the particle executing SHM. So dy by dt is equal to d by dt of a sine omega t. So we get v is equal to a omega cos omega t. A omega cos omega t. So this is the velocity of the particle moving along the circle, can also be obtained by resolving the linear velocity into two components. So this is the first method of obtaining the velocity in SHM, just by differentiating the displacement of the particle, that is y is equal to a sine omega t, and we got the equation as the velocity v is equal to a omega cos omega t. But there is one more method, that is here the linear velocity at point P is the tangential at that point. So v is the linear velocity, and now I am resolving this velocity v into two components, such that we get the two components v cos theta and v sin theta. So v cos theta is the horizontal component and v sin theta is the vertical component of the linear velocity. So here in this figure you can see the two velocity components in the circular path. So the v cos theta is the direction along the OY path. So as we know that from the derivation, that is the projection of the particle, executing SHM. So for one complete rotation of the particle, the foot of the perpendicular makes one to and fro motion, that is one complete oscillation along the vertical diameter. So here The n is the foot of the perpendicular and it makes one complete oscillation during one complete rotation of the particle. So here the oscillation is along the vertical direction. So we have to choose the component of velocity along the vertical direction, that is along OY direction. So here V cos theta is the velocity component along the y direction. So V sin theta is the direction perpendicular to OY and the component V sin theta has no effect along YOY dash direction. So there is no effect of V sin theta on the foot of the perpendicular. So the velocity of the particle executing SHM is V cos theta. So V cos omega t. So theta is equal to omega t. Just I am substituting the value of theta as omega t. So the velocity of the particle executing SHM is V is equal to V cos omega t. But as we know that the linear velocity is equal to omega. So the linear velocity is V and angular velocity is omega. And the linear velocity is equal to r omega. So r is the radius of the reference circle. So here r is nothing but a. So velocity is equal to a omega cos omega t. A omega cos omega t is the velocity of the particle executing SHM. Now we will discuss the special cases in the velocity of the particle. And when the particle is at the mean position, we know that the displacement from the mean position is 0. When the particle is at mean position, y is equal to 0. So the velocity is a omega and it is maximum. So y is equal to plus or minus a omega is called velocity amplitude. And when the particle is at the extreme position, then we get y is equal to a and the velocity is equal to 0. So these are the values of velocities at mean and extreme position. So when y is equal to 0, the velocity is plus or minus a omega, and when the particle is at extreme position y is equal to a, the velocity becomes 0. Now the acceleration of the particle in SHM. So here we know that from the definition of the acceleration, the rate of change of velocity is the acceleration of the particle executing SHM. So we got the relation, the velocity is equal to a omega cos omega t. Just by differentiating the velocity of the particle, we get the acceleration, that is the d square y by dt square or d by dt of dy by dt. So or d by dt of velocity. So simply the d by dt of a omega cos omega t is equal to minus a omega square sin omega t. A omega square sin omega t. But we know that a sin omega t is the displacement. So acceleration is equal to minus omega square y. So here this is the first method to obtain the acceleration of the particle. So here we got a is equal to minus omega square y. So from this equation we can directly conclude that acceleration is proportional to displacement, but it is opposite to the direction of displacement. We got minus omega square y is equal to acceleration. So we from the conditions of the SHM, there we have one point, the acceleration always proportional to displacement and the direction of acceleration is opposite to the direction of displacement. From this equation it is clearly get the knowledge about that 2 points. A is equal to minus omega square y. So this is the first method to obtain the acceleration in SHM. And here to find the acceleration in the second method, I am again considering the same particle is revolving in the circular path x, y, x dash, y dash direction, and here after t seconds the particle is at p point, then the velocity at that point is tangential at that position. So v is the linear velocity at point p. Now as the particle is in the circular motion, so there is a force acting on the body that is always towards the center. That is called centripetal force. The centripetal force always acts towards the fixed point. So towards the center the centripetal force is acting. So centripetal force nothing but centripetal acceleration is also towards the mean position or towards the center. Centripetal acceleration. Centripetal acceleration, as the centripetal force is equal to mv square by r. mv square by r means here r nothing but a. So mv square by a is the centripetal force and v square by a is the centripetal acceleration. So here F is equal to ma. So the centripetal force is mv square by a. So finally centripetal acceleration is v square by a. So in this slide you can see the from point to P the centripetal acceleration is pointing towards the center and the value is v square by a. Now from the triangle ONP, angle OPN is the theta, and I am resolving this acceleration into two components again, along the vertical direction, along the horizontal direction. So the centripetal acceleration is v square by a. So the resolving two components are along the PN direction and along the y direction, So v square by a sin theta is the perpendicular component along the y direction and v square by a cos theta is the horizontal component, it is along the x direction. So v square by a sin theta, v square by a cos theta are the two components of acceleration in the circular path. Now among the three velocities, one is acting towards the center and there are two components v square by a cos theta, v square by a sin theta. So but the foot of the perpendicular is making oscillations along the y direction. So among these three accelerations we have to choose the acceleration along the y direction. So v square by a cos theta is the velocity of the particle executing SHM. So v square by a cos theta is the acceleration of the, v square by a sin theta is the acceleration of the particle executing SHM. Whereas v square by a cos theta has no effect along the y direction, means there is no effect of v square by a cos theta on the foot of the perpendicular, that is the particle executing SHM here. So acceleration is equal to v square by a sin theta. But substitute this v square is equal to a square omega square. Why? Because v is equal to a omega. So by substituting v is equal to a square omega square by a sin omega t, finally we got the relation, that is a is equal to omega square y. So here the particle is moving in upward direction along the oscillation. Suppose the oscillation is in the particle is moving from O to N, the acceleration acting from N to O. So it is towards the center. So that's why we have to mention that acceleration is equal to minus omega square y. So if the particle's direction is along the the displacement is along O y dash, then the acceleration is from y dash to O, always opposite to the displacement. So acceleration is equal to minus omega square y is the acceleration of the particle executing SHM. So the negative sign indicates that acceleration is always opposite to the direction of displacement and is directed towards the center. So this is the acceleration of the particle. Now we will go and discuss some special cases in the acceleration. Suppose when the particle is at the mean position, that is y is equal to simply 0. Then what is the acceleration? Then it is also 0. Why? Because a is equal to omega square y, a is equal to omega square into 0. So we got acceleration is equal to 0. So whereas when the particle is at the extreme position, when y is equal to plus or minus a, the acceleration is equal to plus or minus a omega square, and it is called acceleration amplitude, the maximum value of acceleration, a omega square. So here we have a table here. So I am discussing the values of the velocity, displacement and acceleration of the particle with respect to time, that is the time and the corresponding omega t, displacement, velocity, accelerations. So see here at the time t seconds, so time omega t is equal to 0. At time t is equal to 0, omega t is equal to 0. What is the displacement here? A y is equal to a sin omega t is the displacement of the particle, and the velocity of the particle is a omega cos omega t, and acceleration of the particle is minus omega square a sin omega t. So these are the values of displacement, velocity, acceleration of the particle executing SHM. So I am considering that at different times t is equal to 0, t is equal to t by 4, t by 2, 3t by 4 and finally t, and the corresponding values of displacement, velocity, acceleration. Let us discuss this one. So at t is equal to 0, omega t is equal to 0. So here the displacement a into sine 0. Sine 0 is 0. So simply the displacement is 0. Whereas the velocity a omega cos omega t. So it is a omega cos 0. But cos 0 is equal to 1. We get at time t is equal to 0, the velocity is a omega, means it is maximum. So at t is equal to 0 means it is in the mean position. In the mean position the velocity will be maximum, that is a omega. And acceleration of the particle is minus omega square a sin 0. So it is 0. Next, t is equal to t by 4. T is equal to t by 4. So what is the value of omega t then? It is pi by 2. So whereas omega is equal to 2 pi by t into t by 4. Omega value is 2 pi by t into capital T by 4. So we get pi by 2. So the displacement of the particle is a sin pi by 2, that is a, and the velocity is equal to a omega cos pi by 2, which is 0, and the acceleration is minus omega square a sin pi by 2. We get minus a omega square. And when time t is equal to t by 2 seconds, the omega t value is pi, and again we got the displacement as 0, velocity is minus a omega, and the acceleration is 0. When time t is equal to t by 4, here we got the displacement as a, velocity is 0 and the acceleration is minus a omega square. Minus means at time t is equal to t by 4, the particle is at the extreme position. So at the extreme position the velocity will be 0 and the displacement, acceleration becomes maximum. Y is equal to a and the acceleration is minus a omega square. So again at t is equal to t by 4, the particle is at the mean position. Again we got the values as 0 minus a omega 0. Then if t is equal to 3t by 4, again the particle is another extreme position. There we got the displacement as minus a. Next the velocity is 0 and acceleration is a omega square. And finally at time t is equal to capital T, means at the extreme position, means at the mean position, the way omega t is 2 pi, velocity becomes 0, velocity becomes maximum, displacement is 0 and the acceleration is 0. So these are the values of displacement, velocity, acceleration at different position, means at mean and at extreme positions of the particle. Then this one is the graphical representation of the simple harmonic motion. So to explain this, I am considering the x and y axis. Along the x direction we are taking the time, that is as t, t by 4, t by 2, 3t by 4 and t. Like already we discussed in the last slide. So along the y direction we are taking the displacement, velocity, acceleration values. So finally we got for the displacement graph, it is a clearly sine curve. The maximum displacement is y is equal to a and the minimum displacement is 0. So for from 0 to t by 2, it is from 0 to t complete cycle. So it is 0, a, 0, minus a, 0. So these are the values of the displacement. At 0, t by 4, t by 2, 3t by 4 and t values. Whereas the velocity of the vibrating particle is maximum at the mean position and minimum at the extreme position. So that's why we got the values as a omega 0, minus a omega 0 and plus a omega. So these are the values of the velocity. And finally the acceleration of the vibrating particle is 0 at the mean position and it is a omega square at the extreme position. So here it is also like sine curve, but the values of the acceleration is 0 minus a omega square, 0 plus a omega square and 0. So it values are 0, t by 2, so t by 4, t by 2, 3t by 4 and t. So these are the values of displacement, velocity and acceleration of the vibrating particle executing, means SHM. So sine curves, these are all sine curves, but the values are different at different position, means at the mean position, at the extreme position. Just we are substituting the values of t, small t in the equation. Y is equal to a sin omega t, v is equal to a omega cos omega t and a is equal to minus a omega square sin omega t. Then the time period. Then we go for the time period. So what is meant by the time period? Time period is the time taken by the particle to complete one oscillation is called the time period. So here to explain this time period of the particle executing SHM, and again I am considering the particle is moving along the circular path and the foot of the perpendicular makes a oscillation along the vertical diameter, that is y dash. So after t seconds the particle is at p point. So here the for one complete rotation of the particle, the foot of the perpendicular makes one oscillation, and here I am going to find the time taken to complete one oscillation is nothing but the time taken to complete one rotation for the particle. So here the projection n completes one oscillation as the particle completes one revolution on the reference circle as the center as O and the radius of the reference circle is A. So Finally, the time period is equal to the angular displacement by angular velocity. Angular displacement by angular velocity. And what is the angular displacement? The angle formed in one complete revolution in the radians, it is 2 pi. We know that it is 2 pi is the angle formed in one complete rotation, means angle covered in one complete rotation. So that is 2 pi, and whereas the angular velocity is equal to omega. So totally the time period is equal to 2 pi by omega. But we know that omega is equal to under root of a by y. So how we got this value omega is equal to under root of a by y? So in the last slide we explained I explained this, the acceleration is equal to my omega square y. If we include the direction, it is minus omega square y. But magnitude is equal to a is equal to omega square y. So omega square is equal to a by y, and omega is equal to under root of a by y. So here the time period is equal to 2 pi by omega. So 2 pi by under root of a by y. So t is equal to 2 pi under root of y by a is the time period of the particle executing SHM. Here t is the time period, that is time for one oscillation, and t is equal to 2 pi under root of displacement by acceleration. Here y is the displacement, a is the acceleration of the particle executing SHM. So we got the relation as t is equal to 2 pi under root of displacement by acceleration. Now the frequency. So frequency is the number of oscillations made by the particle in one unit time is called frequency. The number of oscillations made by the particle. So it is simply the reciprocal of the time period. Reciprocal of time period. So frequency is equal to 1 by time period. So mu is equal to 1 by t. But we know that t is equal to 2 pi by omega. 2 pi by omega. So omega is equal to, so mu is equal to 1 by 2 pi under root of a by y. Mu is equal to 1 by 2 pi under root of a by y. So as we know that omega is equal to 2 pi under root of y by a. So here the t is equal to 2 pi by omega, and it is the reciprocal of the time period is frequency. We got mu is equal to 1 by 2 pi under root of a by y. So that is 1 by 2 pi under root of acceleration by displacement. Acceleration by the displacement. So this is the frequency of the particle executing SHM. So in this session we discussed the four physical quantities, the velocity, acceleration, frequency, and the time period of the particle executing SHM. So let us revise these topic. So we know that the displacement of the particle is y is equal to a sin omega t plus phi. So the velocity of the particle in SHM obtained by simply differentiating the displacement expression with respect to time. So y is equal to a sin omega t. So d by dt of y is equal to the velocity, means the rate of change of displacement is the velocity. So dy by dt is the velocity. So we got d by dt of a sin omega t. So by differentiating this equation, we got a omega cos omega t. Then this is the very simplest way to find the velocity of the particle in SHM. only I am differentiating the velocity, so the displacement equation with respect to time. So we got V is equal to A cos omega t, A omega cos omega t. And we have one more method to find the velocity in SHM. So for that, we are including the diagram as we discussed in the displacement for the expression of the displacement in SHM. So the particle is revolving in the circular path as center as O, and the radius of the reference circle is A, and here the linear velocity in the circular path always tangential at that point. So I am considering the particle as at P point after t seconds. So the velocity at that particular point P is tangential at that point. So V is the velocity, linear velocity at point P. But I am resolving this velocity vector into two components such that we got V cos theta along y direction and V sin theta along the x direction. So we have three velocities now. One is V, next V cos theta and V sin theta. Here in this, the particle is revolving in the circular path, but the foot of the perpendicular making the oscillation along the vertical diameter. So the foot of the perpendicular is making simple harmonic motion. Means what is the path of the particle in SHM? It is along the y direction. So we have to choose the velocity component which is along the y direction. So here the V cos theta is the component of the velocity which is along the y direction. So V is equal to V cos theta. And we know that V is equal to R omega, or it is R is equal to A here. So it is A omega cos omega t is the velocity expression. So you can there is a small mistake in this slide. So the velocity is equal to A omega cos omega t. So here it is only omega cos omega t is written in this slide, but it is A omega cos omega t, and cos omega t is replaced as under root of 1 minus sin square omega t. So it is omega under root of a square minus y square. So by if we use the y is equal to a sin omega t equation in this above equation, that is v is equal to a omega under root of 1 minus sin square omega t. Finally we got that v is equal to omega under root of a square minus y square is the velocity of the particle executing SHM. And in the special cases we got when the particle is at the mean position, the velocity is maximum, and when the particle is in the extreme position, the velocity is 0. Means if y is equal to 0, velocity is equal to plus or minus a omega, and when y is equal to a, the velocity is equal to 0. Then the acceleration in SHM. So from the mechanics, the definition, fundamental definition, acceleration is equal to the rate of change of velocity. The velocity is equal to a omega cos omega t. We got a omega cos omega t. To find the acceleration in SHM, we can directly differentiate the velocity with respect to time to get the acceleration value. So A is equal to d by dt of the velocity. So d by dt of a omega cos omega t. So here we got it is minus a omega square sine omega t, and a sine omega t is equal to y. Then acceleration a is equal to minus omega square y. So from this equation, acceleration is proportional to the displacement and it is opposite to the displacement always. So this is simplest method. Only I am doing the differentiation with respect to time. Okay, so we got the final relation as a is equal to minus omega square y. And there is one more method here also. How to find the acceleration in SHM? During the circular path, in the particle is in the circular path, there is a force acting on the body in the circular path. What is it? It is a centripetal force. It is always acting towards the center. And what is the value of centripetal force? It is mv square by r. Means here r is equal to a. So the radius of the reference circle, the centripetal force is equal to mv square by a. Whereas v square by a is the acceleration of the particle. Means the centripetal acceleration is v square by a acting towards the center. But here also I am resolving the velocity components into two components. One is along the y direction. The horizontal component is along the x direction and the vertical component is along the y direction. So here the angle NPO is theta. So along PN direction we are getting one value. Along the perpendicular to PN we are getting another component. So v square by a is along y direction. V square by a is acting along the center and v square by a sin theta is along the y direction. V square by a cos theta is along the x direction. So here also we got the three different accelerations. So which one is the velocity of the particle executing SHM? Here the foot of the perpendicular capital N is making simple harmonic motion and the path of the foot of the perpendicular is along the y direction. So v square by a sin theta is the acceleration of the particle executing SHM. So acceleration is equal to v square by a sin theta. So v is equal to a omega. So v square by a sin theta is equal to a square omega square by a into sin theta. So a get cancelled. We got finally acceleration is equal to a omega square sin omega t. Here small a is actually the acceleration. So from v square by a sin theta, here a is the radius of the reference circle. So to if there is any confusion in this, you can directly use a as r. The radius of the reference circle is r. So why? Because small a generally is used for the acceleration. So you can use the small r for this expression. So acceleration is equal to a omega square sin omega t, and finally acceleration is equal to omega square y. And if we consider the direction of the acceleration displacements, we get a is equal to minus omega square y. Why? Because the direction and acceleration is always opposite to each other. Now the special cases. When the particle is at the mean position, the displacement, the acceleration is 0. And when the particle is at the extreme position, the acceleration is maximum, that is plus or minus a omega square. And here we have a chart here, that is the time versus the displacement, velocity, acceleration values. So here at time t is equal to 0 and t by 4, t by 2, 3t by 4 and t, we have the corresponding omega t values are 0, pi by 2, pi, 3 pi by 2, 2 pi. And the displacement values are, so the displacement is equal to a sine omega t, velocity a omega cos omega t, and the acceleration minus a omega square sine omega t. So we got the values are at the mean position, the displacement, velocity, acceleration respectively 0, a omega 0, then at t by 4, that is at the extreme position, at one of the extreme position it is a, velocity 0, acceleration minus a omega square, and again the particle is the mean position, the displacement 0, velocity minus omega, acceleration is 0, and at the another extreme position the displacement is minus a, velocity 0, acceleration a omega square, and finally the particle comes to its mean position, and that is making one complete oscillation. The displacement is 0, velocity a omega, acceleration is 0. So this is the graphical representation of the SHM for displacement, velocity, acceleration. So these are nothing but the sine curve and cos curve for displacement, velocity and acceleration. So you can see the just by using this chart we can draw this plot, means the time versus displacement, time versus velocity, time versus acceleration. So you can directly get the values. So the students try this diagrams, means plots, the time versus displacement, velocity, acceleration, and find the values and make a chart and make a graph also. Then we go for the time period. Time period nothing but time for one oscillation. So time period is equal to the angular displacement by angular velocity. So as the projection n completes one oscillation, the particle completes one revolution on the reference circle. So the time period is equal to angle covered in one complete rotation is 2 pi, the angular velocity is omega. So t is equal to 2 pi by omega. So omega is equal to under root of a by y. So t is equal to 2 pi under root of y by a. So the time period is equal to 2 pi under root of displacement by acceleration. So this is the time period of the particle executing SHM. And finally the frequency. The frequency nothing but directly we can know that it is a reciprocal of the time period, and the number of revolutions in one complete in unit time is the frequency. So mu is equal to 1 by time period. So it is 1 by t, but we know that t is equal to 2 pi by omega, means 2 pi by angular velocity. So omega already we got the value omega as 2 pi under root of y by a. So the frequency is equal to 1 by 2 pi under root of a by y, means mu is equal to 1 by 2 pi under root of acceleration by the displacement is the frequency of the particle executing SHM. So it is the units are hertz or second inverse, 1 by 2 pi under root of acceleration by the displacement. So this session we discussed a lot of topics, means velocity, acceleration, time period, frequency. So we have two methods. Generally we directly differentiating by mathematical expressions, differentiation using differentiation, and where uh, the physical approachment, that is by using the velocity, linear velocity directions and centripetal acceleration directions, we are getting the values of velocity, acceleration from that the frequency and the time period of the particle executing SHM in this session. So hope this video is very good useful for you students. So but practice well and make the plots also like this. Thank you, one and all.